Welcome to Chibuzor Mathphysics. In the previous video, we talked about mass-energy relation and the derivation of this formula that you can see here, that E is equals to mc squared. So you can refer to the previous video so that you know how we derive this formula. I call it the derivation. You can just type on your net or the Google display the derivation of mass energy relation. That will lead you to that video and you will know how we got to this point. So according to this mass energy relation, or according to Einstein's theory of special relativity, it is good to note that special relativity is also applicable in quantum mechanics, and we talked about how this special relativity is very important in terms of mass energy relation. So according to Einstein's theory of special relativity, mass is a form of energy and they are related by simple and well-known formula, which is E is equals to mc squared, and you can refer to the derivation. So we are going to concentrate more in this video on how we can do some numericals and calculations that involve mass energy relation. So let's take one question and see how to handle that. So let's start with this question, and this first example, I would like us to calculate the rest mass. What is the rest mass energy of a 1 kg block in joules? You can pause the video, try doing it yourself using the formula that I already introduced. That is E is equals to mc squared. So the question wants us to tell what will be the mass, the rest mass energy of a 1 kg block in joules. So using our formula, we know that E is equal to mc squared. That implies that since we have 1 kg, just multiply this by the speed of light. The speed of light is giving us 3 times 10 to the power 8. But remember that here the speed of light is squared. So since it is simply 1 kg, it is simply 1 multiplied by this 3 times 10 to the power 2. That is 3 times 10 raised to power 8 squared. This will give us 9 times 10 to the power 16 It is as simple as that. So this is the answer, 9 times 10 to the power 16 joules. So let's take another question. The second question, I want us to look at this question critically. So what would be the kinetic energy of this 1 kg block if it were moving at 200 meters per second, and that is about 430 meters per hour. So what would be the kinetic energy of this 1 kg block? Remember that we calculated what the rest mass the rest mass was. The first question was, what is the rest mass energy of a 1 kg block? And we got that to be 9 times 10 to the power 16 joules. So I am asking, what would be the kinetic energy of this 1 kg block if it were moving at 200 meters per second? That is about 430 meters per hour. Pause the video and try doing it yourself. Of course, you will still continue with our formula. E is equals to mc squared. So we're looking for the mass. The question is asking us what would be the kinetic energy, and we know by mechanic 1 and even mechanic 2, we know that kinetic energy is given by a half mv squared. And we know the mass of that object moving, it is 1, because it says what would be the kinetic energy of this 1 kg block if it were moving at 200 meters per second. That is about 430 meters per hour. So to do this, kinetic energy will therefore be a half multiplied by 1, which is the mass, multiplied by V. V is given as 200, but in this case we know it is V squared, so it is 200 squared. This will give us approximately, if you put this in your calculator, you get 20,000. And 20,000 is nothing but 2 times 10 to the power 4 joules, to the power 4 joules. So this would be the kinetic energy of this 1 kg block as required. Let's look at the next question. The next question says, what is the rest mass energy of the neutron, which has a mass of 1.68 times 10 to the power negative 27 kg, and we are to express the result in a EV. EV simply means electron volts. So we need to calculate the rest mass energy that has this mass, 1.68 times 10 to the power 20 negative 27. Of course, it is still the same thing that we did using our formula E is equals to mc squared. So let's see how to do that. You can pause the video and try doing it yourself. So using our formula E is nothing but mc squared, and this is equal to our mass of this neutron. It is given as 1.5. We have 1.68 times 10 to the power negative 27. So this is what we have. Of course, this is kg. This is kg. And then c is the speed of light. We know that speed of light is given as 3 times 10. It is 3 times 10 power 8 squared, because it is c squared. If you multiply these two things, we will get this will give us 1.5 times 10 to the power negative 10 joules. But remember that we are to express our answer in electron volt. Since we have the answer in joules, we need to convert this to electron volt. We know that 1 electron volt is equal to 1.6 times 10 negative 19. So since we have 1.5 times 10 to the power negative 10 joules, multiply this by 1 electron volt, divide this by 1.6 times 10 to the power negative 19 joules. Of course, joules, we cancel joules, and when we multiply these together, we'll have 9.4 times 10 to the power 8 electron volt. This can as well be represented to be 940 mega electron volts. And this is what we expected to do in this video. We can take one more question and then we conclude this video on mass energy relation. Let's take one more example. So this last question, you have to pay very attention. An electron and positron. A positron is a positively charged electron, each having 10 electron volt collide and annihilate into pure energy. So how much energy is carried away after the collision? Read that again. The electron and positron, that is a positively charged electron, each having 10 kilo electron volt, collide and annihilate into pure energy. How much energy is carried away after the collision? It is very simple. You can pause the video and try doing it yourself. But first of all, think about it. Is energy conserved or is energy lost? Is there energy gained? Or what actually happened when there is collision? So let us pause the video and try doing it yourself, and then you will figure out the answer. Okay, let me show you what to do. So the simple solution to this problem would be that since we have electron and positron, and these two electrons and positron each having 10 electron volt. That tells us that the total energy is conserved, so it must be the same as it was before the collision. So if we had 10 in the beginning, it was 10 keV, and then after the collision it is still 10 electron volt. It is still 10 electron volt. We simply need to add these two things so that we will simply have 20 kilo electron volt, and this would be the solution to this question. Of course, what it tells you is that the total energy is conserved. There is no energy loss, nor are there energy gain in this case. So we've talked about so many things on how we come up to this formula E is equals to mc squared, and I had referred you to the previous video where I did the derivation so that you know how we arrive at this point. Of course, we did the first question that talks about the rest mass energy of 1 kg block. We also proceeded to determine the kinetic energy of this 1 kg block if it were moving at some 200 meters per second. And then we come up to the third question that we were to talk about the rest mass energy of a neutron, which has some mass. I think it was around 1.68 times 10 to the power negative 27. And finally, we had this question that helped us to know that if an electron and positron, which is a positively charged electron, each having 10 kg, 10 electron volt, and annihilate into pure energy, how much energy is carried away after the collision. And we know that since both the electron and positron have the same energy, so the total energy is conserved. We cannot say that there is energy loss or there is energy gain. So simply add the two energies, and then we have 20 electron volt. And this will be the end of this video. We'll continue our next video on mass energy relations, problems, and other numericals that sometimes look too difficult for us to handle. I remain your friend, Augustine Galagash.